Every year around the world, floods ruin cities. For most people, floods tend to be quite an issue. However, there are some people out there who aren't bothered by them. We want to focus on the people who do see flooding as an issue. Every year, some U.S. cities are plagued with floods, some of them being New Orleans, Tampa, and everywhere in Key West, which was the inspiration behind our idea. The design is quite simple and includes a lot of very simple technology that people tend to love, such as sewer grates, rafts, which everyone always loves, and the good old-fashioned water wheel. Before we get into how our project works, let's take a minute to discuss how hydroelectric power actually does work. Water goes through an intake. The water is usually kept within some kind of reserve or reservoir. As it goes through the intake, it meets a turbine. The turbine, which in our case is the water mill, spins. With the spinning comes energy. The energy from the spinning of the turbine or water mill or motor goes into some sort of generator. From the generator, it is then pushed out through cables into long-distance power lines. It's quite simple how it works. It's the same as burning coal or anything where energy is being created, but it's done with simple mechanics and movement and the flow of water. In our project, the reserved water would be coming from the flood water. The turbine would be our water wheel, and the generator would be the motor attached to the back of the water wheel. From here, which this is all the same as the way actual hydroelectric power works, this can power the grate. The motor will connect to some sort of system which will be waterproofed if put into actual production, that will then connect to a chain system up on top where the grate is that will pull the grate away from the ground, which then opens this up to go into the sewers as well as release a raft out into the streets for people to use. This is all simple hydroelectromechanics. When you put this all together, you get a safety device that is built into city streets that's powered by water, which what else would it be powered by if it was coming from a flood?
So when a high flood area has common floods, this will be installed in the drainage systems. What it will be is a drainage grate that has two pipe systems instead of one. The common drain system for normal water, and when the drains start overflowing from high amounts of water, such as floods, tsunamis, hurricanes, and such, the water, before it starts overflowing out the drain, will go into a second piping system, and the second piping system will drop the water down into a water mill. This water mill will spin and obviously create electricity, which will power a motor that will pull the drainage grate back from the road, raising a raft up for safety of other people.
There's some interesting design features that went into making the actual project. One of which was the production of the parts that we needed. For creating the grate as well as the back splash plate that protects the motor from water, Shane and I used the laser printer in our school. This allowed us to cut the acrylic out into the exact size that we needed for our parts. We also took full advantage of our school's MakerBot 3D printers. With these, we were able to create the funnel that we used to collect the water that went down the tube to power the water mill. Sure, by now, the thought of money has come into your head, and how this is going to be, financed, and how expensive it's going to be. The thing is, this could potentially be expensive, but at the same time, it could be run on a lower budget. Of course, getting engineers to design this for actual use in a city will cost money, as well as the installation of it. You're going to have to take segments of sidewalk and cut holes in it, and then install this stuff. However, if we use the resources we have now in modern technology, such as higher quality 3D printing, we can create these parts out of waterproof and durable plastics that we can design on the computer with free software that can be created. Although it can potentially be quite an expensive design, there are a lot of ways to do it cheaply. And then again, when you think, isn't human safety in these flood-prone cities more important than a couple dollars spent out of the city's budget? The safety aspect of this project is really what makes it so marketable. It's more marketable towards city councils and the government than it is to consumers buying at Walmart or something. But that's more important than just consumers, because if you take this to like the city safety council and you put it forward as an idea, being that this is truly a problem in some cities with flooding, especially New Orleans, this idea can be taken and put into real life and real design. And that's why I am so happy with the way this design came up in the process, is that it does have purpose. It can be done and it can be used, especially using alternative fuel sources, like using the actual disaster to power a disaster relief is what makes this project so special. And to me, that is more important than anything that you can buy in hopes of making a flood better. And that's why this idea should be put forward to city councils.